Today we are going to study probability and statistics, and we have studied before that the random experiment is an experiment in which we can determine all of its possible outcomes, before carrying it, But we cannot predict certainly which of these outcomes will occur when the experiment is carried out. بمعنى ان الراندوم اكسبيرمنت يا شباب هي تجربه عاديه جدا اقدر احدد كل الاوتكمز اللي هي النواتج المخرجات ممكن اسميها الريزلتس. ايه الريزلتس اللي ممكن تظهر عندي؟ كل الاحتمالات انا عارف ان هي حاجه منهم هتظهر، بس ما اقدرش اتنبأ مين بالظبط اللي هيحصل. زي ايه؟ زي هنا عندي ده اسمه دايس. When throwing a dice once, أنا عارف مسبقا إيه اللي ممكن يظهر، يا ولاد؟ 1 or 2 or 3 or 4 or 5 or 6. Okay, so I predict what may result when throwing a dice once. Also, I can predict when throwing a coin. This is one coin. This is called head. And this is tail, and I can predict that head or tail will appear. But I cannot say exactly which one will appear. So in the random experiment, I know all the outcomes, but I don't know what exactly will happen. Next concept is the sample space. The sample space is the set of all possible outcomes of an experiment, of a random experiment. So the sample space is the set of all possible outcomes for a random experiment. Like what? Throwing a dice once. What is the sample space of throwing the dice once? So the sample space equals 1 or 2 or 3 or 4, 5 or 6. So this is the sample space of throwing the dice once. What is the sample space? Sample space of throwing a coin once. Okay, what's the sample space of throwing a coin once? So the sample space equals head or a coin once. If we want to find the sample space of throwing a coin twice, so the sample space will be like this. If I have a coin, I will throw it twice, so that the first time will appear head or tail. Okay, so this is a coin, head or tail will appear, and the second throw, head or tail will appear. Also, head or tail will appear. Which makes the sample space head, or the two faces, the two heads will appear. Head or tail, head and tail. Okay, tail and head, tail and tail. So this is the sample space of throwing. Now an event. The event, it is a subset of a sample space. It is a subset of the sample space. It's a part of sample space. جزء يعني من sample space. And the number of elements represents the number of times of occurrence. For example, of an event, A is the event of getting odd number when throwing a dice once. What is the event? What is the event A when throwing the dice once of getting odd number? So the event A, which is odd, pair of odd numbers, appears on the dice are 1, 3, and 5. 1, 3, and 5. For example, the same problem. If throwing a coin or the dice once, what's the probability of getting? Make it be even number. What's the probability of getting even? It will be 2 and 4 and 6. We cannot take more than 6 because the dots on the dice are 1, 2, 3, 4, 5, and 6. Okay? So the probability, C is the probability, the event of getting prime number. Prime. So what are the prime numbers on the dice? 2, 3, and 5. Another problem. What's the probability of getting? Sorry, the D is the event of getting a number less than or equals to 4. What are the numbers that are less than or equal to 4 on the dice? So this is the numbers will be 1, 2, 3, and 4. All of this, now throwing a coin, throwing a coin once. What is the event A of getting head? The event of getting head equals head only, because there is only one head on the coin. B is the probability is the event of getting tail. So only one tail exists on the dice. This is head, and this is tail. Okay, so the event B is the event of getting tail is tail. Okay, so all of these are called events. To check what is required and find the event. So now we are going to study what types of events. What are the types of events? There are 3 types of events. One, the first type of events is called certain or sure event. Certain or sure event. And we symbolize it by S. Okay? Like what the certain event, like what? Like the sun rises from east. The sun rises from east. Yes, it's a fact. So it's certain event, it's sure event. Okay? Okay, this is very important. Also, day comes after night. This is a certain event, it's a fact. Also, as we have studied before, that the probability of certain event equals 1. The probability of certain event equals 1. The second type is impossible event. Impossible event. We symbolize it by 5. Okay? Impossible event. That impossible to happen. Okay? Like what? It rains gold. It rains gold. Does it rain gold? No, it's impossible. So this is impossible event. Okay? Also, the sun rises from west. Okay? So this is also impossible event. It cannot happen. Okay? In daily life. Also, as we have studied before also, that the probability, this is very important, probability of certain event equals 1, but the probability of impossible event, probability of impossible event equals 0. Equals what? Equals 0. Okay? The third type of event is possible event or probable event. This event may happen, may not happen. Like what? Like I will go to school. I will go to school in Sunday or at, I don't know, Sunday, in Sunday. So I may go, I may not, okay? It will rain tomorrow. It will rain tomorrow. It may rain or not. So this is called possible event, possible. Okay? The probability of possible event lies between what? If you know, raise your hand. Yes, Mumtaz, Yusuf, say lies between, yes, lies between 0 and 1. Lies between 0 and 1. So it's probability of possible event we can say that it's greater than 0 and smaller than 1. It's a proper fraction, proper fraction. Like maybe half, like third, 0.75, and so on. So it's a proper fraction, not greater than 1 and not smaller than 0. Okay? Now we want to find the probability of events. How to find the probability of an event? The probability of an event equals the number of elements of the event A over the number of elements of the sample space. Okay? Like what? Find the probability when throwing a dice once. What is the probability of getting odd prime number in the upper face of the dice? Okay, so what are the prime the prime odd numbers on the dice? These numbers are 3, 5 only. 2 is prime, but it is not odd. Okay, so this is the number. How to find the probability? So the probability of A equals, what are the numbers? What is the number of the event A is 2. What is the number of sample space? Sample space of the dice are 1, 2, 3, 4, 5, and 6. Okay. So how many element? 1, 2, 3, 4, 5, 6. Over 6. So the probability of getting odd prime number equals 2 over 6. We can simplify by dividing by 2. Okay. 2 divided is 1. 6 divided is 3. Okay. So this is an example only, and more problem we will study about it. Okay. About the probability. Okay. So what is the sum of all probabilities of an experiment? As we know that if we add the probability of getting head plus probability of getting tail, what is the probability of getting head? 1 over 2 faces of the coin, plus probability of getting tail is 1 over 2. It's half plus half equals 1. So the sum of all probabilities of an experiment equals 1. This is very important. Also, if I want to find the probability of non-occurrence of an event, equals 1 minus the probability of the occurrence of the event itself. We called it probability of A dash. A dash means A complement or complement of A. We have studied before. So probability of A complement equals 1 minus the probability of A itself. Now we take an example about this this point. It's very important. Okay. If the probability of success of a student is 0.8, the probability of success of a student is سيب لو سمحت الشات بليز لو سمحت سيب الشات وخليك معي. If the probability of success of a student is 0.8, then the probability of his failure. So success and failure are different, or we can say mutually exclusive events. So we'll subtract from 1. Subtract from 1. 1 minus 0.8. 1 minus 0.8 equals 0.2. Oh, this is a very important point. Okay. Now we'll take some exercises about it. Okay. About probability in general. Okay. In the experiment of selecting at random from 7 equal cards numbered from 1 to 7, write the sample space. Write the sample space. So we have to first to write the sample space. So the sample space equals, what is the sample space of cards numbered from 1 to 7? 1, 2, 3, 4, 5, 6, and 7. Okay, so this is the sample space. So now find the probability of events. So we have to find the event first and then find the probability. Where A is appearing a number less than 4. So event A is the numbers that are less than 4. What are the numbers less than 4 from these cards? 1, 2, 3, and 4 not included because there is no equal. So now I have to find the probability because he asked mainly about the probability. So probability of A equals 3, 1, 2, 3 over the total number of sample space is 7. Okay? The event B is appearing of an odd number. Odd number. So B equals, what are the odd numbers on this cards? 1, yes, very important. 1, 2, 1, 3, 5, and 7. Okay, so the probability of B equals 1, 2, 3, 4, 4 over 7. Okay, C is appearing a number more than 5. So C equals, what are the numbers which are more than 5? 6 and 7. Now we can find the probability of C equals 1, 2 over the total number of sample space over 7. Okay, so if you read the problem correctly, you can find the answer correctly. Okay, the next problem is in an experiment of tossing a regular die once and observing the number of dots on the upper face. What is the probability of A? The event A appearance of a number less than 5. What are the numbers that are less than 5? Okay, so this is A and this is B. Okay, so A equals, number less than 5 are 1, 2, 3, and 4. Okay, so we exclude 5. Not 5 is not included because less than only, not equals to 5. So the probability of A equals 1, 2, 3, 4, 4 over the total number of the sample space of the dice. What is the sample space of the dice? 1, 2, 3, 4, 5, 6. I mean throwing the dice once. Okay, 1, 2, 3, 4, 5, 6 over 6. If you want to simplify, divide by 2. 4 divided 2 is 2. 6 divided 2 is 3. Okay, B. What is the event B? The event B, where B is the event of appearance of a number satisfies the inequality, B is greater than or equals to 3. What are the numbers on the dice that may appear greater than or equals to 3? 4, yes, you are right, 4, 5, and 6. But there is equal here, so 3 included. So 3 is included, 3, 4, 5, 6. Okay. What is the probability of getting of the event B? The probability of event B equals equals how many elements here? 1, 2, 3, 4. So this is 4 over the total number of dice, sample space is 6, 4 over 6, also will be 2/3. A box contains 8 white, 12 red, all of them are symmetric. A ball is selected without looking inside. Without looking inside means randomly. Okay, means randomly. Find the probabilities of. The selected ball is white. So we have to find the total. So the total number of balls. So the total equals, which will be the total number of sample space, 8 plus 12. 8 plus 12 equals 20. Now you can find the probability of getting white. Probability of getting white equals how many white balls? 8. 8 over 20. You can simplify by dividing by 4. Equals 8 divided by 4 is 2. 20 divided 4 is 5. Okay, so I think it's very, very simple. Selected ball is red. So this is, okay, we can find it like this. Probability of red ball is the number of red balls is 12 over the total number of sample space over 20. Also, we can divide by 4. 12 divided by 4 is 3. 20 divided by 4 is 5. Okay? Now, the selected ball is blue. Is there any blue ball here? No blue ball. So, probability of blue ball, because this is impossible event, equal 0 over 20 equal 0. This نبدأ نحل كده بعض البروبلمز on probability في المسائل اللي عندنا. بقول a class contains 20 boys. يبقى the number of boys is 20. And the number of girls is 15. If a pupil is chosen at random, then the probability that the pupil is a boy. First, you have to find the total number of pupils. Okay? The total number of pupils equals 20 plus 15 equals 35. Okay? 35. Now you can find the probability of getting a boy. The probability of getting a boy equals the number of boys is 20. 20 over 35. Okay, if you want to simplify, no problem. You can simplify by dividing by 5. 20 divided by 5 is 4. 35 divided by 5 is 7. Okay? Hope it's clear. It's very clear. I think so. A letter is selected at random from the name As-Salam. The probability selecting the letter A. So, how many A's is repeated in this name? 1, 2, 3. So, to be 3 over the total number of the name. 1, 2, 3, 4, 5, 6, 7. So, 3 over 7. The probability of impossible event, as we have mentioned, equals 0. The sum of probabilities of all outcomes of an experiment equals 1, as we have mentioned also. Okay? The probability of success is 0.8. Then the probability of the failure of his failure equals the probability of complement of an event equals 1 minus 0.8 equals 0.2. Okay? I think it's clear. As throwing the dice once, the probability of getting a number divisible by 7. Is there any the number of the dice as we know 1, 2, 3, 4, 5, 6, 7. Is there any number is divisible by 7? No, no number is divisible by 7, so the probability equals 0. This is an impossible event. A box contains 5 red, 3 blue, 2 yellow balls. Then the probability of drawing a red ball. So see, the number of red balls is 5. 5 over the total number of balls. 5 plus 3 plus 2. Total number of balls, 5 plus 3 plus 2 equals 10. By dividing by 10, all the number of red divided by 10, you can simplify by dividing by 5 equals, okay? So this is some problems about probability. Also, if an experiment of tossing a metal coin wants a probability of getting a head, how many heads on the coin? 1. What's the total number of faces of the coin, as we have mentioned? 2. So you have half. Probability of getting half. Of getting head. Also, the probability of getting tail is the same. A letter is selected randomly from the word prime. The probability of selecting the letter M. How many M's here repeated? 1, 2, 3, 4, 5. So the total number is 5. How many M's? Is 1. 1 M. So 1 over 5. So it's select 5. Okay? Okay. So also another problems we can do this problems. A class contains 40 students. 32 of them are succeed in test. This is the probability of failure. The probability of failure. Okay. So first you have to subtract succeeded students. So failure students equals 40 minus 32 equals 80 students. Now we can find the probability of the failure students. The number of failure is 8 over the total number of students is 40. 8 divide 40. No 8 divide 40, you have to simplify by dividing by 8, because 8 and 40 are divisible by 8. 8 divided by 8 equals 1. 40 divided 8 is 5. Okay? Another question, he says, so 1 over 5. So the answer is 1 over 5. If the probability of winning a game is 0.8, then the probability of losing the game, so the same problem as we subtract from 1, 0.8 equals 0.2. Yes, this is the answer. Okay? Okay. So if a die is tossed once, then the probability of getting a number satisfying the inequality x greater than 5 and smaller than 6. This is 6 not. When tossing the dice once, we want a number lies between 5 and 6 on the dice. If that exists, this will be a fraction. Is there any fraction on the dice? 5.5 or 5.25 or 5.75? No, there is no fractions on the dice. So this is impossible event. Its probability equals 0. A card is drawn from a bag of 25 card numbers from 1 to 25. Calculate the probability that the card of the number divisible by 5. What are the numbers divisible by 5 on the dice? Starting from 1 to 25, there are 5, 10, 15, 20, and 25. Okay, so what's the probability of event A, which is divisible by 1, 2, 3, 4, 5 over the total number of cards is 25. We can simplify by dividing by 5, it will be 1 over 5. A perfect square, what are the numbers perfect squared starting from 1 to 25? 1 is perfect square, 4 is perfect square, because 1 times 1. 4 is 2 times 2, 9, 16, 93 times 3. 16 is 4 times 4, 25. Also 5 times 5. So it's a perfect square. So the probability of B equals 1, 2, 3, 4, 5. 5 over 25 also equals 1 over 5. A box contains 5 red balls, 8 green, and 3 yellow, and 4 black. A ball is selected at random. A ball is selected at random. Find the probability of. Find the probability of red ball, getting a red. So we have to find the total. First, total equals 5 plus 8 plus 3 plus 4. Okay, so 7 is 15, 15 plus 5 is 20. So the number of red, the probability of getting red are 5 over 20 equals 1 over 4. Green is 8 over 20. You can simplify by dividing by 4, so 12, 2 over 5. not black, not black. The numbers which are, the colors which are not black are 5, 8, and 3. So 8 plus 8 is 16 over 20 equals 4 over 5.